Hello everyone, it's been a while since I've uploaded anything, but today I do have something to show you. A bit of a background story first. Back in October, I joined 3 friends of mine to participate in the NASA Space Apps Challenge. It's a hackathon organized by NASA, and the way it works is there are a bunch of local events spread around the world, and each of those local events will have a bunch of people participating, and they will select one winning group in that local event. And then all of those winners of those local events will participate in the global competition. And NASA then chooses, of those participants, they will choose 10 winners. So NASA has 10 different categories, and in each category they will pick one winning team. The reason I'm making this video today is because we won one of those awards. We won the Best Use of Science award, which of all of the different awards, that's a pretty cool one to win. And so I wanted to show you what we made because I think it's pretty cool. So NASA provided us with, I think, 11 different challenges we could choose from. And the one we chose to do was to make a virtual orrery that displays near-Earth objects. So an orrery, back in the day, it used to be a physical thing that displays the positions of the planets in the solar system. Nowadays, it's usually an app or something that displays like the planets and dwarf planets and things like that in the solar system. And so our challenge was to make an app like that that would display not only the planets, but also near-Earth asteroids. Now, the friends I joined, Max, Ian, and Dakota, they are all doing meteor physics research. And so we decided to not only make something that displays near-Earth asteroids, but also implement showing the meteor showers and meteor distributions in the solar system. Because while they don't pose a threat to life on Earth, they do pose a serious threat to space infrastructure, like things like satellites, astronauts when they're out of the ISS and stuff like that. Well, the ISS itself as well, I think. And so it's something that's often overlooked when talking about threats in space, but it is something very important. And so we decided to implement that in our app as well. So without further ado, let me show you what we made. All right, here we go. So this is the app. It's a web app. It's up on my website. I do have a website now. I'll put a link in the description so you can check it out if you want to. So here we go. We have the orbits of the different planets. So all the way in the middle here is Mercury, then Venus and Earth, Mars, and so on. So those are the colored orbits. And then the gray orbits are dwarf planets. So for example, here we have Ceres. You can click on it. It shows you some information. It also has a position somewhere, I think. Let me just, there we go. Here is Ceres. Shows you little ball. And then same goes for the planets. So you can, for example, click on Earth's orbit here. There we go, that's Earth over there. And we'll show you some information. Things like it's a planet. There we go. It has a mass of 1 Earth mass. Very interesting. It has a rotation period of 1 day. It has a semi-major axis of 1 astronomical unit. Funny how that works. It also has an inclination of 0 degrees. That's a coincidence. So anyways, then there's time controls at the bottom here. So you can speed things up to 1 year per second, which is quite fast. But then, like, for example, like 1 day a second to a week a second are speeds that work quite well. You can see Earth spinning around here at the bottom. So those are the planets. Then you can show near-Earth objects here. It's a lot of them. These are all the ones that are implemented in our app. And these are all near-Earth asteroids that are listed on a risk list. This is from, I think it's from a database of ESA. It might be NASA, but I'm pretty sure it's ESA. And so we took all of that data of those objects, and then we made it in here. And so you can filter these asteroids based on their properties. Like for example, the risk you can select for high risk asteroids, and then on size you can also take like the larger asteroids. That will drastically limit the number of asteroids that are shown here. And so every single of these red orbits is one asteroid, and they will have these white balls on certain positions, and those are the asteroids. So we can target one of these. And so this is asteroid 2005 ED224, a very interesting name there. And so this will be the correct position of that asteroid for this date and time. It will also show some information, like for example, the diameter, the impact risk on some scale. I don't really know the specifics of this scale. I'm not doing asteroid research, as well as orbital parameters here. The first possible impacts, for example, would be something interesting. And it also has like the time window where possible impacts might occur. So this asteroid has possible impacts between 28 and 64. Well, 2028 and 2064. So that's the asteroids. We can also show meteor showers. So if I speed time up a little bit to like one beat per second, you will see some, like a month a second, there we go. You will see some blue orbits appearing and disappearing here. And those orbits are meteor streams. So they're streams of little debris that follow a certain orbit. And whenever Earth passes that orbit, or passes through that orbit, those meteor showers are shown in our app here. It's based on this time, of course. And so those meteor showers, they correspond to a certain parent body. So the way this works is those parent bodies are, for example, comets, that whenever they, for example, pass close to the sun, they will like break off some chunks or something, and then those form the meteor shower. And for some of the meteor showers, those parent bodies are actually known. And for those known parent objects, we have their orbits, and those are shown in dark blue here. So for example, I can select this guy. It's 2004 TG10. And that will show this position right here. And that's like the parent object of the meteor streams that roughly follow this orbit. So there we go. That's meteor showers. Apart from meteor showers, there's also something called the sporadic meteor complex. And this is a distribution of meteoroids that is centered on the sun. So this is the distribution. It's centered on the sun, and the directions of those meteoroids are basically random. And it's just a bunch of little pebbles and stuff that orbits the sun in random directions and random orbits. And so this shows the distribution of those meteoroids. There we go. So that's everything in our app. I thought it's pretty cool. So we made this on the 5th and 6th of October. In total, we worked on this for 25 hours. And that was our submission for the NASA Space Apps Challenge. I decided to not change anything on my website, even though it's all over now. I decided to not change anything about this on my website because I wanted to keep the original version. I thought it would be pretty neat to just have this as being the thing we created in 25 hours. And so if you want to check it out, it's up on my website. I'll have a link in the description so you can check it out. That's everything I wanted to show today. Thanks for watching, and I will see you in another video.